Alright, so we're ready for testing. Now I want to go back to the ground terminal. I want to explain another thing, is that your insulation resistance measurement is performed from X1 output terminal to ground. So if you don't have that ground connection, I won't be able to give you a valid insulation resistance measurement. It checks between those two terminals. So I just wanted to point that out. Now let's turn it on. It's going to go through its boot up page, and well, by default the unit will stumble onto F1 tests page, and I'm going to zoom this here so you can see this a little better. As you can see, F1 tests, F2 CT information, F3 graphs, so this will be where you'll get your saturation graphs, tabulated information, the results, this would be your report page, and test plan. But most likely we're going to be starting with a test plan, and this will allow you to either select or create your own test plan. Now I'm going to zoom back here and I want to show you that we have a rotary knob here, and this allows you to move through the selections and select or confirm some selections here. Now let's go back here and zoom this so you see this a little better. Now if I want to select a test plan, I just got to bring the cursor to that little arrow here and press down on the rotary knob, and then this selection pops up. So I can choose now this here 10418 because, well, that's the serial number of the CT I'm testing right now. And I had already previously entered the information about the test's different parameters. So in this case here you'll see voltage maximum. What is that and how important is that? Well, let's refocus here. Now this selection here is actually the maximum voltage that we're allowing for us to run the tests, the injection. In this case here is 450 volts. There's a rule of thumb that says that you should apply 0.5 volts per turn. In this case here it's 600 to 1, and yes, it says 450 volts, but that rule of thumb, this is a good example of that rule of thumb is not perfect. It's just a good starting point. So you can just, again, press down on the rotary knob, either turn it either ways, or you can directly punch in the number with the keyboard. So, and I press down again to confirm this selection. Then we move to secondary amps. Well, that's the information about the secondary output of this CT. Most commonly we have 1 amp and 5 amp CTs. Again, I press down, turn the rotary knob, and press down again to select. So in this case here, in this CT, it was 1 amp. Then I want to run an insulation resistance test, or I can press down and deselect it or remove it from the test plan, but in this case I do want it. I turn the rotary knob, and now I'm entering data about the ratios for every tap. You'll notice that we have 10 different selections here. So from X1 to X5, and then all the inner taps, so X2 to X3, X2 to X4, etc. Alright, now again we press down on the rotary knob, turn the knob to select a different ratio, or I can use the keypad and say, for example here, 44 by using the keypad. But really it's 40, so let's bring it back to where it was. Do I want a ratio test? Well, maybe not. Just by pressing or depressing the rotary knob, I can select this. Do I want an excitation test or saturation test? Yes or no. Winding resistance? Again, yes or no. And so on and so forth with all the different other tabs, and you can move through this. Now we do have a last selection at the bottom here that might speed up things a little for you. Either we select all tests at the bottom over here, all tests, or we can actually go down to a little further where it says none here, and if I select this, they all disappear. I go back, I can select them all back on again. So that's how we would run or create, modify a test plan. Once we're satisfied with all of this, then we can go back here, right up here, and the Save menu, and press the button, and it's going to save it into its internal memory. We have a lot of room there for hundreds of test plans. So have fun with this. Now once we've recorded and saved a test plan, and you can name this, you just got to press again in this box, and you can select other characters and use the keyboard to enter the name of this test plan. Once we've selected the test plan, we're satisfied with this, then we're going to go back to the F1 button, and we're going to select this. It's going to bring us to the test page. We don't necessarily have to do this, but it can be interesting. You can still remain in this test plan page and press, here let me zoom out and show you, press the Start button. By pressing the Start button, automatically it will bring me to the F1 test page, and you can now view what's going on. Now it's flashing here, insulation. So the insulation resistance is completed. It's greater than 1 gigohms, which is great. Now it's running the winding resistance. Finish the winding resistance. Once this is done, it's going to run through its demagnifying process, and then rerun excitation and ratio information. So the measurements will instantaneous values, but we'll see the last results here, and we also see the saturation graphs while things are being performed. So you have a direct interaction with what's going on while it's going on, which is convenient. If there's anything that seems a little awkward or weird, you can react to it right there and then. By that, you also see that you see here there's a little LED high voltage, which means, well, there's voltage being injected here. So we want to be careful about that. Also, there's the emergency knob. And if I press down on this, it's going to stop everything. It's going to kill my output completely. So, and then you just got to turn it clockwise to unlock it, and things will get back to normal. You might like to check this, as sometimes when you're starting testing and you press the Start button, things are not working. Well, you might have accidentally pressed this button, as you see, to unlock it and have things return to normal. So this is a pretty smooth process. Right now, I know that I've completed test number 4, and it's going to keep on doing this all automatically until it's completed all 10 tests, as I selected it in the test plan menu. Now, insulation resistance is only available from X1, the first test, X1 terminal. So it does it the first initial time, and then it doesn't go back to it since it doesn't need to. The windings from X1 to X5 are really all connected. So we just run the test from X1 to ground the first time, and then that information is saved into memory, and we then continue the steps using, of course, in this case, if it's selected, the winding resistance, excitation, and ratio. There we go. Oh, very simple, very intuitive. This should be a breeze to demonstrate. All right, we've completed the tests. Test number 10 is completed. Now let's look at the data I can press the F3 button if we're interested in looking at all 10 graphs simultaneously. So it's going to process all the data and then show you all the graphs. We can look at tabulated reports, F4. And what this is basically every single data point that was sampled to create those graphs. So for test number 1, which is X1 to X2, I can move this again with the rotary knob and select that I want to see not the points from 1 to 20, but let's say from 11 to 30, or etc. So I can view any points that was used and sampled to create those saturation graphs. The F5 button is your report. Basically, in a nutshell, this is your report. Most people out there would appreciate. Now, as you see, we have all the IEEE standards. IEEE 30. This is saturation knee point marker points. So we have the IEEE 30, IEEE 45, and the IEC 1050. There's the nameplate ratio information. This was a 40 to 1. The measured ratio was 40.14. The error between the nameplate and the measured ratio is, in this case here, 0.3%. Winding resistance, as we've seen earlier, 2.13 milliohms. Insulation greater than 1 gigaohm. And the phase deviation is 0.3 degrees, and the plus means positive polarity. Now, you can move this information to X1, X3, X1, X4, etc. down to the very last one, which is X4 to X5, which is our last test, just by moving the rotary knob. And you have some information about the CT itself. And where does this information come from? Well, yes, from CT information. Now, you can enter all kinds of information here. Serial number, company, the station, operator, designation of the product, the manufacturer, ratio, again, voltage rating, the position, if it's on circuit breakers. In some cases you'll have top, middle, bottom CTs. And you can enter that. Which phase it is, the class of the CT, temperature of, if that's interesting or important to you, the ambient temperature. And whatever notes you think it'd be interesting to have in there, you can enter here and save this data. And once you're done, well, alright, you can go here in this record button, press down, and it will save it into memory. Once you're done, the very convenient method here is to use a USB stick and put that here and the USB stick port, and you can then download the data to your PC. There's one more thing you can do, very, very simple. There's a little printer button right here. So if I press the printer button, there's a printer menu that's going to pop up. The short report, the long report, paper feed, I can do that, or completely reset the data. Now, the short, I think this would cover most your requests or most requirements out there for printouts. It's a condensed report, and it gives you all the data except the sampling points that were used to create the saturation curves. So let's go ahead and do that. Print the short report. Alright, so it's going to print out the information about the CT tester, then print out the information about the not the CT, yes, the CT that we're testing. So that's that. Alright, so we've recorded the data into internal memory, we've printed it out. Now we can save the data to a USB thumb drive. And so I put the USB thumb drive in its port, and I'm going to press the menu button. And I'm going to zoom in so you can see what's happening on the display. So operation mode, then I can move the rotary knob to USB memory, and there pops up a message saying transfer to USB memory. Well, I confirm that that's what I want to do, and it's going to take the files that are in the memory first. I should say it's going to check the integrity of the USB stick, and it's going to transfer the data, the number of data files to the USB stick, and then I can view them using our report manager software, or simply by any text program. It's ASCII files, so you're not tied to the manufacturer's software, even though we believe that is going to be a lot more convenient to view the information using our report manager software that's included with the instrument. Alright. Now I'd like to show you a little bit about a special troubleshooting mode, or I think you can use this for troubleshooting mainly because in some cases you'll have applications where people or some certain setups will bring you in front of CTs where you can't even read any nameplates, either because they've been erased over time or haven't been tagged properly. Well, here's a feature that can get you out of trouble when you're faced with this kind of situation. Now, see, what I'm doing right now is I'm actually X1 terminal, X5 terminal, which is the complete winding of the CT, and I'm putting X1 on X1 and X2 terminal on X5. Now, I'm going to do that because it allows me to measure the full winding. Let's say I have no idea what this CT is, or what's the ratio, or all that good stuff, and well, I need to perform a test. So here's what we can do. We can set the unit in a manual mode. So I use the control button and M. This is a shortcut. So control M, and now I'm in a manual mode, or troubleshooting mode, if you'd like. So let me zoom into that and show you exactly what we're looking at. By default, this is going to select a 0 to 600 volts injection range, but you can change that by pressing down on the rotary knob and selecting different ranges. It goes from 0 to 50 volts up to 0 to 2000 volts. Now let's select by default 0 to 600 and press the start button and start injecting and ramping up the voltage. Let me show you here. Slowly but surely ramping up and turning the knob and increasing the output voltage. Now already you can have information about the voltage, instantaneous voltage output, the current. In this case here, you're seeing the secondary side voltage. You're seeing the ratio, which is a 600, and that's exactly what we had. 600 to 1. 0.2 phase deviation, polarity is positive. So and I'm going to increase the voltage. Now, not only does this give you information to create your own test plan if you don't have any information available, but as you can see lightly here, I'm seeing a graph being created, and I'm already up to 103 volts. I'm continuing ramping up, and this will tell me up to what voltage I need to saturate this CT, because it's going to kick out and kick out on its own once it's reached saturation. See, I'm already seeing that little curve there, so I'm almost at my limit. And I can hear it humming already. Through 175, 283. There we go, 309 volts. So, knowing this, I know that this CT is a 600 to 1 ratio. I know that I'm going to need at least 300 volts to run a saturation test. And I know the phase is, the polarity is good. The phase shift is very small, 0.2. And that's it. That's enough information to start creating your own test plan. Because in some applications you won't have any information to read from or refer to. And this can help you out and get you out of trouble. Now, not only does the CTT5 and X2 measure the quality and different parameters from the CT, but it would also allow you to measure the connections or the leads that would be attached to the CT. So we're looking at the circuit that's going from the CT back to the relays, and we're measuring the impedance of the relay, the cable resistance, and we're giving you your burden. So to do that, we would connect to the burden circuit with the burden test leads right here. So we have a burden circuit of 20 volts, 20 amps, 400 VA, and we connect these test leads. I have it hooked up right now to a resistance, and well, this is just to simulate, just a resistance right here. But in normal circumstances, you would take the test leads that's coming from the relays and you hook them up to these two test leads. Now, to go into the burden mode, again, we can use some shortcuts. Control B for burden, and now the screen is going to appear like this. I'm just going to press start and have the output current go through the resistance. And this is a 1 amp CT, but see, if I bring it back down to 1 amp, alright, so I'm having 695 milliohms, or in this case here, roughly 700 VAs. That's what I'd be measuring. This is simulating the load that the CT would see. Then again, you might have some CTs that have 5 amp output. So I'm going to increase the output to 5 amps. And here we go. Of course, the impedance didn't change, but the VA that I'm outputting and that this circuit is being able to see is much higher. So 17 VAs, or close to. And well, once you're done, press stop, and that's it. It freezes the information, kind of like a measurement hold. And that's that for burden testing.